All right, let's talk about a little bit of just the basic trig. These are the basic skills you should be able to do. And really, you're going to get a lot of these practice in 7.02 on that delta math. So this is the type problems in delta math that I think are really going to help you. So anyway, when you solve for a side, um, you're going to be given this information right here. You're going to know an angle. You're going to be missing one side. That's what you're solving for, and you're going to be given one of the sides. So these are the two sides that are involved. This side is not involved. So your first idea here is to decide which trig ratio really is this. From this angle's point of view, this over here is the opposite side. So I know I'm using the opposite. And this over here is the hypotenuse. We can tell that from a right triangle. And so the O and the H tell me that this is opposite and hypotenuse. So I need to go look up the sine ratio of 35. And the way we do that is we go to our calculator and we check the mode and make sure we're in degree mode. We are. And then I type in sine of 35 and I get this ratio. All right. And that means that side compared to this side is we 0.57 to 1. So maybe you can think of it this way. It's a little over half of this side because 0.5 would be exactly half. All right. So I'm going to type that in. I get that number right there. I put it over 1. I think about my algebra right here to get x all by itself, and you figure out that side is 7.5. So that's just one of the basics. You're given an angle and a side, and you're solving for a missing side. All right. Let's look at another one. That's like the most basic idea of trig. Solving for a side again. I'm given an angle. I'm given one side, and I'm solving for this side. All right. So as I look at this one, though, the 58 right here, if I look across from there, that's the opposite side. And this is the hypotenuse. We're not using the hypotenuse, so I know I'm not using this one or this one because that stands for hypotenuse. And this is the adjacent side. So that's opposite and adjacent. So it's the tangent ratio. That's how I'm deciding this. So I need to go look up the tangent ratio of 58. For all 58-degree angles, I know the opposite compared to the adjacent is in that ratio. So I write it down and put it over 1 and think about the algebra right here, which means I'm going to end up dividing when I do this algebra. You should be able to follow that algebra right there and solve for x when it's on the bottom. And by the way, x can be on the bottom. You have to follow opposite over adjacent. You can't just make it up and put x on top because that's not what this number is telling you. That's the number when you compare the opposite over the adjacent. So we have to solve the problem that way. Okay, so there's another one just like the previous problem. All right, solving for an angle. All right, so if we know these ratios for every angle, we should be able to look this up backwards. So if I'm missing the angle right here and I'm looking and I know the ratio of two sides, see now I have two sides given. I'm still doing the same idea right here where I figure out that this is the hypotenuse. I know this side over here is the opposite we're not using yet. So that means this side right here is the adjacent. So which one uses adjacent and hypotenuse? Well, I need to go think about SOHCAHTOA. So it's cosine. That's the one I'm going to use. I still set my problem up the same. That's the cosine of the angle equals adjacent over hypotenuse. In your calculator, you're going to have to type it in to do stuff backwards. You're going to hit second cosine. That's the inverse cosine. It brings up that little -1. And then you type in the fraction right there, 10 divided by 14, and it'll tell you the angle. There's only one angle that could fit. It's 44.4 degrees. Let's see, if that's 10 and that's 14, that's the only angle that can fit in there because that's the way right triangles are built. All right. The only other type of problem, and this is probably more over there in your homework, was solving a problem that didn't have a triangle drawn. It didn't have, it just had some given information. It said the tangent of x was equal to z over 10, and the cosine of x was 10 over y. So that was all you knew. And it said to find the sine of x. So you're thinking, well, how can I do this? I don't even know what x is. But you just think about this. The tangent is the opposite over adjacent. So you got to remember SOHCAHTOA. So that means the opposite is z, and the adjacent is 10. I wrote that out. And over here, cosine is adjacent over hypotenuse. So the adjacent right here is 10. And again, the hypotenuse, we verified that up there anyway. But the hypotenuse I just learned is y. So now I know what all three of them equal. I can just go and do the sine ratio without having to do any math. I'm just plugging in numbers in an opposite over hypotenuse because we know sine is opposite over hypotenuse. So opposite over hypotenuse. Well, the opposite is z, and the hypotenuse is y. So there's my answer right there. The sine of x would be z over y. So I just used SOHCAHTOA to figure that out. I didn't have any numbers to deal with. I mean, it had the 10, but we didn't have to solve anything. All right. So maybe that's some help that'll get you going on some of those problems. Remember, this always reverts back to SOHCAHTOA. That's your three ratios that we need to know and memorize.